Hello all. In this video, I am going to introduce you to how to do regression analysis using Julia. Julia programming language is a new language and it's comparatively new compared to R or Python. R and Python was released, the first version was released in 1990s. Whereas Julia's first version was released in 2018. So Julia is a comparatively new language. The advantage of Julia is, I find, twofold. One is expressivity. That is, if you want to write a particular code or something, it is much easier in terms of its expression. And second advantage, I find that Julia programming language tries to take the advantages of new compiler theory, new advantages and advancements of the compiler theory. So it tries to implement all the functionality faster than R and Python. So when we are trying to crunch lot of large big data, the Julia turns out to be very useful. So I am going to start how to do regression and classification, particularly regression, in this video using Julia. So first I will start a Google site, and in Google, if you just say download Julia programming language or Julia for Windows, you can write Julia programming language, or you can say for Windows, or then you will get it will take you to the latest version of Julia, and here you get Windows, Mac, generic Linux. Typically, if you are using a Ubuntu system, this version should work. So I am using MacBook, so I with M series processor. So in my system I am going to use this Julia. Now, if you open Julia, then basic Julia console will open in terminal. So it will open in terminal. So that's how it will behave. So for example, if I want to say alpha and then press tab, then it give me the alpha, and then I can use assign 2, and then if I say beta and tab and I say 3, then it gives me if alpha and beta are two variables now we have defined. And then, so let me just increase the size. So, and then if I just say alpha plus beta, then it gives me 5. So alpha, beta you can define as variable here, because Julia do allow Unicode. In fact, certain advantages is that if you can use some, since it's do Unicode, I have Bengali script installed here. So if I just say ka, it's a Bengali script, and so say 2 and then ka equal to say 4, and then ka plus ka, it's giving me 6. So in fact, if you have Hindi script, or if you have Kannada script or Tamil script, you can install it, and you can define your variable name with so if you have any, you can define your variables in using your local regional language, and this I find is very helpful in terms of expressing the equations and other things. So but using writing everything in the console is a bit difficult. I mean, when typically I generally use VS Code, and in the VS Code you have to go to the VS Code is very useful in terms of when I do some project based development, I typically rely on VS Code. But for teaching, I find the Jupyter Notebook is very useful. So I'm going to open Jupyter Notebook. Here is I'm opening my Conda fast. Now I'm going to launch my Jupyter Notebook, and here you can see Jupyter 1.8.2 version I have, and now I'm going to use the Jupyter Notebook in our I'm learning the regression with Julia. So first thing I will do, I will first code block I'm going to create as a markdown regression with Julia. So if I just run it, it will give me the heading. Then first thing I will do, I'm just going to call some our data sets. These are the packages. These are the Julia packages that I'm going to call our data sets, plots, and GLM. Now what our datasets does, it is a Julia package which essentially from the different popular R packages, it takes the dataset and gives you the data here. So all the popular datasets like mtcuts dataset and the diamond dataset in the ggplot2, all those dataset is automatically available in Julia. So this is a very useful, I find this is very useful. And then what I'm going to do, I'm going to call the diamond dataset from ggplot2 I'm going to call it diamonds dataset. So let me just run it. Sorry, here is a spelling mistake. Yeah, there is no error now, I believe. So first, and if I just say first, comma, say 6 and run it. So what it will do, it will just plot the first 6 rows of the data set in the diamond data set. Now what we are seeing that diamond data set has about 10 columns, 3, 4, 5, 6, 7, 8, 9, 10. Caret, cut, color, clarity, depth, table, price of the diamond, and then XYZ. There is a concept of table of the diamond and what is the length, breadth, and height of the diamond. So those dimensions are given here, XYZ, and these all have very important effect on the pricing of the diamond. So first, if you just and it is read as a data frame. So like pandas data frame in Python and data frame in R, Julia also has a data frame, and this data frame is also very useful. This data structure, particular data frame, is very useful. Next, if I just say names equal to names of diamonds, so it gives us the names of the all columns. Okay. Now similarly, if I just say names, the seventh one, if I just call that seventh one, so it is the seventh one element is price. So now name is a vector. Essentially it's a 10 element vector of all strings. It's a vector of strings. This essentially extracting all the column names of the data frame. So the first thing what I'm going to do, from the data, this data frame, I'm going to take the price and the color caret. The caret is also a continuous variable, like float 64. Price is a integer 32 bits integer, but let me just call these guys. So price equal to diamonds seven, and caret equals to diamonds comma. So this exclamation marks means you take all the rows essentially. NMS 1. So no error so far. Now what I'm going to do, I'm going to run from the plots, I'm going to call the plot function. Okay, caret comma price. If I just run this, so you can see it is plotted as sort of a series. Typically by default plot tries to plot as a time series, so that's why it's slightly weird. I would like to see a scatter plot here. So what you have to say is series type equals to colon scatter. So now it is giving you the scatter plot. Now but it's saying y1, so I don't want the y1. It is still treating it as a sort of a caret as the index here, and the price as if y series, time series. So what I want, I don't want the label. So what I'm going to do, I'm going to say that don't put me any label. But if you see, there is no labeling of the x-axis or y-axis. So I have to put some labels. Plots dot x label caret C-A-R-A-T and plots dot y label price. Now if you run, now you can see the price and the caret. As the caret increases, you can expect that the price will increase as well. Next, I want to fit a linear regression maybe between caret and the price. So what I will do, what kind of model I will fit? So I will fit price equals to beta naught plus beta 1 times caret plus var epsilon, the error part. Now if you run it, this is the model I want to fit, so we can just write it like this. Sorry, we want to fit the following regression model. Okay, so if we just run it, so this is the model we want to fit. Fitting this model is almost same as fitting a regression model in R. So you just call model. So let me just say model 1. We will try some other models as well. So lm, you call lm @ formula. Now in formula you have to give what model you want to fit. So you say price tilde caret, caret, and then you have to give the name of the data frame. So the name of the data frame where both variables are available. Okay, now if you just run it, so it ran. Simply I will write model 1. Let me just have it run it. So you can see that it has fitted a model with the coefficient. This is the beta naught. So we can say the beta naught value is beta naught. So we can say beta naught equals to -2 this. Second is we can just copy this line here, and beta 1 is 7.756.43, and then standard error of beta naught is equal to 13.0533, and standard error of beta 1 is 14.066. Okay, and then what we can do, we can also say what is the t value. If you see this -2.52256 divided by 13.0533, you see this is -172.83. the t value is here. And similarly, if you just take 7.56 divided by its standard error, then you will get the t value is here, 551. So that's how the t value is being calculated, and p value is calculated from the t distribution. The model, now we want to fit another model. We want to fit, say, not only caret as a function of caret, price as a function of caret, but we want to also fit the function of cut, the second feature, which is a categorical variable or string variable. Now, what model that will be? So the model that will be is something like this. So price equal to beta naught. So before that I want to write that we want to fit a model for price which will be function of price which will be function of caret and cut. So now if you run it, so okay, let me just have a tell here. So in fact, one thing we can do just to make sure that tell that this price is actually coming from data, it's a variable, you can just put it like this, and then it will be, you know, termed as price. Okay, next is, or we can say capital P, this is capital C, and this is capital C. Now, price is a function of beta naught plus beta 1 times caret, maybe I just say it like this, plus beta 2 times cut. So this is what I actually want to fit. So okay, we can do that. So we will fit a second model. So model 2, all you have to do, you have to just add the end plus cut, and model 2 is this. But now you see within cut there are different values are there: good, very good, premium, and ideal. There are, you know, 4 different values are coming. Actually there are 5 values of cut: fair, good, very good, and premium and ideal. So what kind of model that is actually fitting? What it is fitting is, it is indicator function of cut equals to good plus beta 3 times indicator function for very good plus beta 4 indicator function for premium plus beta 5 indicator function for ideal. Indicator function, or you can say the one hot encoding or what dummy variable. For each string you are creating a, you know, indicator functions. Okay, so this will be a var epsilon. Okay, so this is the model actually you are fitting. So you have intercept, then 1 2 3 4 5, so 6 total, 6, 1 intercept caret 1 2 3 4, good, very good, premium, and 1 2 3 4 5 6. So 1 2 3 4 5 6. Yeah, there are 6 coefficient is being estimated: beta naught, beta 1, beta 2, beta 3, beta 4, and beta 5. So there are 6 total, 6 coefficient are being estimated. Now if suppose now this is the model, these are the coefficient of the model, these are the standard error. So if you divide the standard error with by the coefficient by the standard error, you get the t value. You can see the t values are very large, p values are very small, almost 0. It is even less than point after 100 zeros 1. These are the 95% confidence interval. So none of them include 0. So that means these all coefficients have a significant effect on price. So we are not going to, that is what the statistical analysis says. Now, after fitting the model, what we are interested in for a particular new diamond, can we estimate the expected price for a new diamond? Okay, sorry about that, I think I just made a mistake. Okay, yeah, so this is fine, and now this is the part I have to make mark down. Okay, for a new diamond, with diamond of 2 carats and with premium cut, can we estimate the expected price? So suppose this is the question that we are interested in. This is a new diamond which is not part of your diamond data set. Now given you have trained this model, you have fitted this model, now given this model, you want to estimate the expected price of this new diamond, which is of 2 carats and premium cut. So that means I can say carat equals to 2 and cut equals to premium. Okay, then what is the expected price? This is what my goal is. From the model, can we do that? So the first is, so if we just plug in this, so in fact this is my whatever the beta naught, this is my first value. Let me just copy this. This is my beta naught, then plus beta 1. So this is the beta 1 times carat plus beta 1 times carat equal to 2. Now, is it a good? No. So that means this is 0. If you look at the model, this is the model. Since it is not good, so it will be 0. So 0 times beta 2, whatever the value, it is 0. Very good? No. So this is 0. Premium? Yes, it is 1. If it is premium, it is 1. So beta 4. Beta premium value is 1439.08 plus 1439 times 1. Okay. So now if I run it, so 13305.77 is the price, expected price. I am not saying it will be the price. So because if you look into this, so 2, so 13 is somewhere here probably. 13,000 is somewhere here. Somewhere here. So it can be anywhere. The range is very large, you can see. But at least you can get some kind of expected price to be in that region. Now we will take a little bit shift and we will go to some cross check of OLS method. So let me do, let's cross check some concepts of OLS method. Okay. So remember that I fit this model as model 2. So what I'm going to do, I'm going to extract the design matrix. So I can write each model, all these model as a y equal to x beta plus model x beta plus epsilon. So what I can do, I can just say model matrix of model 2 and write it as a x. Okay, let me just see. So this is my x matrix. It has 53,940 samples with 6 columns. Now first column are all ones because it corresponds to the intercept. Second column are all corresponds to the values of caret. Okay, the third column corresponds to the cut equal to good. Wherever it got good, it says 1, other rest of the places it 0. The fourth column is corresponds to very good. Wherever it got very good, it gives 1, rest of the places it gives 0. And similarly it is premium. Wherever it got premium, it is says 1, rest of the places it's 0. If any value with the ideal condition, then it will say 1 and rest of the places will be 0. So that's how one-hot encoding works, or ideal dummy variable creation or indicator variable creation works. So this is my design matrix. Okay, so once I have the design matrix, what I will require next thing is the response variable. So y equal to model response. Okay, so these are my prices of 53,940 prices. Okay, now what is the OLS estimator? The OLS estimator is beta hat beta equals to x transpose x inverse x transpose y. Okay, so this is the OLS estimator. So what I'm going to do, first I'm going to calculate x transpose x. So I already have x, so I'm going to calculate x transpose x. So this is my x transpose x matrix. So you can see that there are about 53,940 samples. The first will be n. Then out of these samples, this small block represents how many of them were good, how many of them were very good, how many of them were premium, and how many of them were ideal. So if you add them up, I think you will get 53,940. Now if you just say x transpose x inverse, say -1, so you get the inverse of x transpose x matrix. And you can see this, it's very intuitive. The way you write write it on your notebook, the way you write it in the in the blackboard, almost you can codify it. You can write your Julia code almost on the same way, the way we have written it, almost in the same way. and then I'm going to calculate X transpose Y. So these are my X transpose Y elements, and now I'm going to calculate X transpose X inverse X transpose Y. So X transpose X inverse times X transpose Y. So if you just, so these are the elements, and then from the model 2, now remember that if I go up there, here is I have the model, I have fitted model. From the fitted model, if I just extract the coefficients, it will give me the coefficient values. Now carefully check, all these values are almost same actually, up to 8 or 9 decimal places they are almost same. Okay, so LM, when we are calling LM here with formula, price, caret and cut, they are essentially what it is doing, this particular entire call, creating the X matrix, creating the Y matrix, and then running this ordinary least square estimation and estimating the coefficient values. Along with it, it is also estimating the standard error, also estimating the t values, p values, and the 95% confidence interval. So now you can see that how to do, typical fit a simple regression analysis model using Julia. Thank you very much. Let's meet in the next video.